In this video, we're looking to solve the polynomial inequality. The quantity x plus 3 squared times the quantity x minus 1 squared is greater than or equal to 0. The graph has been provided here. So we see that we have x-intercepts at -3 and +1, -3 and +1. And this +1 has a multiplicity of 2, so our graph is just touching there. So what is this question really asking us? Now, because this is asking where it's simply greater than 0, what this is really saying is where is this polynomial above the x-axis? If it was greater than or equal to, it would be where is it above and touching the x-axis, but since it's just greater than, we want to know just where is this graph above the x-axis. So we're looking for positive values of y and what intervals of x give us that. So we know that at our zeros, that's where our graph is going to, that's the only place that a graph can change from positive to negative. So we want to look at our zeros. So our first zero is here at -3. So we can see that to the left of -3 for values less than -3, our graph is going down. It's going to be below the x-axis. If we look at values to the right of -3, we see that our graph starts to go above the x-axis and is therefore positive. At -3, our graph is equal to 0, so we can't include it, so we use parentheses there. And we see that it's above the x-axis all the way until we hit here at the other x-intercept at 1. So again, at 1, it's equal to 0, so we have to use parentheses. We can't use brackets. So for all of our x values in between -3 and 1, we can see that any of those values in that interval are going to give us a y value that's positive. So that's the first part of our solution set. So from -3 to 1 is the first portion. We actually have another interval where this graph is increasing, or where it's entirely above the x-axis, right, where it's greater than 0. And it's to the right of 1. So we can see that if we look at values to the right of 1, our graph, rather than crossing through the x-axis at 1, is going to turn back up because of this multiplicity of 2. So it never actually becomes negative in this section. It just reaches 0. But again, we know that we can't equal 0 here, so we're going to have parentheses. We're going to have parentheses. And then it's just going to be everything to the right here. Everything to the right of +1. So it's going to be the interval from 1 all the way off to infinity. So that's the solution set in interval notation. If you were writing the solution set in set notation, it would be the set of x such that this is saying x is in between -3 and 1. So -3 is less than x is less than 1, or x is greater than 1. All values of x greater than 1. So that's the solution for this polynomial inequality.